Hello, everyone. So our next algorithm, like you can see on your screen in the classification algorithm, is going to be nearest neighbor. A very simple and a very famous one, and very easy to understand. But obviously, it has some challenges that we might face in the industry to once we implement it. The nearest neighbor algorithms, and one of the challenges, it's not very good against the outlier, and we're gonna see one of the reason why we are saying it. Let's first look at the nearest neighbor. So like you can see from the algorithm name, what it does, it actually pick the nearest neighbor from the distance perspective, and it used the Euclidean distance, which is very famous one, and easy to calculate if you still remember your algebraic days, and if you remember your Pythagoras theorem, where we actually calculate the value of diagonal based on the side, the height and the base, right? So it works exactly based on that. And I'm considering at the moment with the two-dimensional space, but obviously once we go into higher dimension, it will change accordingly. But unfortunately, we cannot display more than 3 dimension. So the concept is gonna remain same. If you understand it from the two-dimensional perspective, you can safely increase the higher dimension, and the algorithm work without any issue. So how the algorithm works, what it does, it actually look at the nearest neighbor. So based on the distance from the point, so for example, we have an unknown object and we want to classify that object. So what we will do, we'll actually check the distance of that point in the surrounding to the neighbors, and we just pick the nearest neighbor. And how many neighbors you're gonna pick, that will define the k. So that's why it's called k nearest neighbor. So for example, if I'm going to ask to pick the 3 nearest neighbor, then the value of k will be 3, and it will look the 3 nearest neighbor and look at the classes of those neighbor, and based on that, whatever the maximum class is going to be, or the most common class is going to be, that class will be allocated to the unknown object. So that's how the k-nearest neighbor works, which is very simple to understand. But you can see, if the data points are not have a quality issue, or if the data points are not classified correctly, so it's going to actually impact straight on the quality of the prediction of our k nearest neighbor classifier. So that's what I'm saying. So there are some limitation why it's not gaining a lot of popularity in the industry, beside its simplicity. All right, so coming back towards the math is pretty easy. So you can see, like I mentioned, obviously we have two-dimensional space. So you can see we have one point as we called it P, the other point we called it Q. Now, the distance between P and Q, if we actually draw on the two plane, so obviously we are going to have X plane and we are going to have Y plane. So now assume that point P, if we draw a perpendicular line, it's going to actually connect to x-axis at point P1. Just give it a name at point P1. And then obviously, if we draw the same straight line from point Q, that's gonna be, let's say, point Q1. Right now, we'll see and do the same thing on the vertical line. If we drag the line all the way to the y-axis, then we just call it point P2. And then if we drag similar the point of Q all the way to y-axis, we're gonna call it Q2. Right, so that's a very simple one. Now, like I mentioned, the whole mathematics works based on the Pythagoras theorem, which is obviously defined, and you might have proved it in the 10th grade, because I did. So what the formula is, the square of the diagonal, because if we draw a triangle, so you can see. So sorry, before we go into the equation, the distance between this point up to the point where it is it is joining to, the q point is joining to the x-axis is obviously is going to be q1 minus p1, because up to this point the distance is p1 and up to this point is distance is q1. If we minus subtract p1 from q1, then it's obviously gonna give me this distance, right? Now how about this distance? So obviously we know up to this point we have q2 and up to this point we have p2. So if we subtract p2 from q2, we're gonna just get this much, right? So now based on these two value, I can safely apply. So if I want to calculate this distance, the solid line distance, which is obviously, if you remember, is we normally represented with c. So that c square is going to be a square, which is showing the altitude, and the b square, which is obviously the base, right? But in here we have the value. So the diagonal is going to represent as the distance between p and q. So we're just showing it, and then we know that our base is q1 minus p1 square plus q2 minus p2 square, right? And that's going to give me the distance. And obviously if I'm gonna actually get the actual distance, because at the moment based on the Pythagoras theorem it is coming as a square, so we're just gonna take the under root on both sides, and d of p comma q, the distance between p and q is going to be the full under root of q1 minus p1 square plus q2 minus p2 square. So very simple mathematical derivation that you can easily understand. And based on that, we just calculate the point. So maybe let's go to the other diagram. Now I'm gonna show. So for example, let me just drag the demo at the moment. Let me just hide it. All right, so you can see we have the green object, and we want to classify, and we are talking about, let's say, three nearest neighbor, right? So k value is going to be 3. So in this diagram you can see the nearest neighbor to point green is going to be this blue, and it's going to be these two red triangle, because all other points they are further from these 2 points. Obviously all these red, they are out from the zone, and these blue squares, they are also outside of the zone. So based on the value of k, it's going to be these 3. Obviously if we increase the value of k to 5, then we can cover the additional 2 points, which is obviously going to be these 2. So that's where like I mentioned, the quality of data is need to be robust or very high if we want to classify it correctly, because obviously if we have k value is equal to 3, this object is going to be classified as red triangle. However, if we increase the value of k is equal to 5, then you can see the majority vote is going to be blue square, right? So the object is classifying as blue, right? So that's the challenge that we normally face once we use the k nearest neighbor algorithm. But obviously we have more types of k nearest neighbor. We have reverse k nearest neighbor, and then we have the inverse nearest neighbor. So there are many derivations that the research has driven in last 1 or 2 decades to just improve it, right? But just to give you the simple understanding, that's how the k nearest neighbor classified work, right? So now obviously our next step is to have a demo in the PySpark. So we're gonna see how this algorithm shines. So I'm gonna see you in the next video. Hope you like it. It will definitely benefit you from the understanding perspective. Thanks for watching, and stay tuned for the demo.